There are many formations with multi-zone oil and gas reservoirs that are vertically drilled and stimulated using hydraulic fracturing to optimally recover these hydrocarbons. In this example, we show a well targeting 3 sandstone layers, although this number may vary in different oil and gas plays. Once the drill rig and other infrastructure is in place, a bit mounted on the end of the drill pipe begins drilling the well. The well is initially drilled to a designated distance below the deepest fresh water source near the surface. The pipe and bit are then removed and surface casing is inserted into the hole. The casing is then secured into place by pumping cement through the casing and through the shoe at the bottom of the hole. The cement barrier and steel casing prevent any contamination of freshwater aquifers. Once the casing cement has set, drilling of the intermediate section of the hole continues by drilling through the wiper plug, shoe, and cement at the bottom of the wellbore and on toward the targeted zones. Throughout the drilling, a mixture called mud is pumped down into the well through the drill pipe. The mud serves to keep the drill bit cool. It carries the cuttings to the surface and provides hydrostatic pressure, prohibiting formation fluids from entering the wellbore. As drilling approaches the depth of the first target zone, a technician called a mud logger is brought on location. He analyzes the cuttings, identifying the downhole lithology and any presence of hydrocarbons. As the well is being drilled, he provides real-time information to the company geologist and rig personnel. Once the bottom of the intermediate section is reached, the drill pipe and bit are again removed from the wellbore, and intermediate casing is inserted into the hole and connected to the surface casing. The intermediate casing is also cemented to secure the hole. The drill pipe and bit are again lowered back into the hole and drills through the wiper plug, shoe, and cement. Once total depth is reached, the drill pipe and bit are removed from the wellbore one last time. Next, a logging tool is lowered to the bottom of the well on a wire line. As the tool is pulled back up the entire length of the well, data is gathered to create an electric log. Once the well has been logged and deemed a commercial well, production casing is then inserted. As with the surface and intermediate casing, the production casing is also cemented into the hole. Back on the surface, the drilling rig is no longer needed. A temporary wellhead is installed and the location is prepared for the service crews who will ready the well for production. The first of these steps is to perforate or perf the casing. A perforating gun is lowered by wire line to the lowest of the 3 target zones. An electrical current is sent down the wire line to the perf gun, setting off a charge which shoots holes through the steel casing, cement, and out a short distance into the target formation. The perf gun is then pulled out of the hole. The next step is to hydraulically fracture or frack the zone. Here, sand or other proppants are pumped into the wellbore under extremely high pressure. When the mixture reaches the target zone, the pressure forces it out through the perf holes and out into the sandstone formation, causing it to fracture. This creates a fairway connecting the reservoir to the well, inducing the released gas to flow to the wellbore. Next, a bridge plug is placed inside the production casing, isolating the fracked zone. The hydraulic fracture process is then repeated for zones 2 and 1. Now that the frac process is complete, the plugs are drilled out and production tubing is lowered into the wellbore to reach each of the productive zones. Hydrocarbons can now flow simultaneously from each of the zones into the well. Up to this point, the process is the same as drilling a vertical well. Again, the pipe and bit are pulled out of the hole, and a downhole drilling motor with measurement while drilling instruments is lowered back into the hole to begin the angle building process. The distance to make the curve from the kickoff point to where the wellbore becomes horizontal is just under 1/4 mile. Once the curve is completed, drilling begins on the well's horizontal section, called the lateral. The pipe used to drill the well measures 30 feet in length and weighs approximately 495 pounds each. It takes over 350 pieces of pipe weighing nearly 87 tons to drill a 10,500-foot well. At various stages of drilling, the pipe is taken out of the hole for tool and bit changes and put back in. This process is called tripping pipe. When the targeted distance is reached, the drill pipe and bit are removed from the wellbore one last time. Production casing is now inserted into the full length of the wellbore. Cement is again pumped down the casing and out through the hole in the casing shoe, forcing the cement up between the casing and the wall of the hole, filling the open space known as the annulus. Casing the well is a very important process because it permanently secures the wellbore and it prevents hydrocarbons and other fluids from seeping out into the formation as they are brought to the surface. At this point, the drilling rig is no longer needed. A temporary wellhead is installed and the location is prepared for the service crew who will perf, frack, and prepare the well for production. The first of these steps is to perf or perforate the casing. A perforating gun is lowered by wire line into the casing to the targeted section of the horizontal leg. An electrical current is sent down the wire line to the perf gun and sets off a charge that shoots small holes through the casing and cement, and out a short distance into the sandstone formation. The perf gun is then pulled out of the hole. Next, because the sandstone is tight, the well will have to be fracked. Known as hydraulic fracturing, this is a process where water, sand, and additives are pumped into the wellbore and down the casing under extremely high pressure. As the mixture is forced out through the perforations and into the surrounding rock, the pressure causes the sandstone to fracture. This creates a fairway connecting the reservoir to the well and allows the released gas to flow to the wellbore. Next, a temporary plug is placed at the heel or left side of the first stage frac. The plug closes off or isolates the perforated and fracked section of the wellbore so that the second stage section of the horizontal leg can be perforated and fracked. Tight reservoirs do not contain natural fractures and therefore cannot be produced economically without hydraulic fracturing. The permeability is increased by providing pathways through which gas can flow more easily. With advancements in technology, multi-stage fracking has become the standard for tight gas reservoirs. This process of perfing and fracking can be repeated several times to cover the entire horizontal distance of the wellbore. Once fracking is completed, the plugs are drilled out, allowing the gas to flow up the wellbore. The next step is to install a permanent wellhead, also known as a Christmas tree, and other necessary surface equipment. A pipeline is then built to transport the gas to the pipeline network. As field development expands, additional pipeline infrastructure is built. Thanks to the vision and persistence of those who have perfected these new technologies, unconventional gas plays across the U.S. have become an innovative and highly productive source of energy for our country.